Right, cool. Right, welcome to Cheltenham Digital, because it's not Cheltenham Geek Nights. If you haven't come before, got a bit of a different subject. So I was introduced to Paul by Toby, who's a long-time geek. And some really interesting subjects, something a bit different. And we've done lots of, if you haven't been to Geek Nights before, we do sort of a mixture of software stuff and electronic stuff. And we try to sort of alternate a bit. So we've done loads of software stuff lately. So somebody else coming in. Yeah. So it's good to have an electronics one. I think I've heard lots of money going to the pot, but if anybody hasn't seen and wants to give a £3 donation to the space, to Deep Space Works, that's brilliant, thank you. And that's it. I think talk and then loads of questions, and here we go. Right.
Thank you. So I haven't got any set plan, I haven't got any PowerPoint slides. What I'm going to do is talk a little bit about who I am, where I've come from, where I am now and how I got there. And then I'll talk a little bit about these bits and pieces as well, in case you're wondering what they are. And then if you've got any questions, I'll do my best to try and answer them. So, my name's Paul Maddox. I got interested in electronics when I was about 7 or 8. I was given a television by my grandmother that didn't work, and being a sort of keen child on taking things apart, I pulled it apart and had it working in about 2 hours, much to her annoyance, so she just bought a new one. This was a colour television, which was quite expensive way back then. So I've always had an interest in anything electronics and bits and pieces, and I think for my 10th birthday, my parents got me an electronics kit. It was a book, I can't remember what it was called now or who it was by. And it was basically, here's a pile of circuits, and you went out and bought all the bits and you put them together, and you could make like a flashing light and a buzzer and a little organ and things. It was brilliant for a 10-year-old, it was fantastic. So that's when I first got into electronics, been tinkering with them ever since. Did the whole, secondary school thing, scraped a few O-levels just. Went to college, got an HNC in electronics and marine telecommunications. Sounds grand. It was great fun, get to play with things like radars and magnetrons. For those of you who not know what a magnetron is, yeah, it's a thing in a microwave that cooks your dinner. Couple of 100 watts usually. Radar ones tend to be sort of 10 kilowatts or more. They glow nicely and they do hurt. So that was part of the fun with it. That's where I got my interest in electronics. I got bored doing college, as I usually do when I'm doing study. Left and got a job at a university working with computers, and I kind of got stuck working with computers for about 20-something years. In that time, I was fortunate enough to meet a few people who were interested in synthesizers. I think it was the mid-90s I created an online magazine called Modulus E-Zine, which was basically me and a few friends would get together, share a few schematics, write a little PDF and publish it online on a... what was it? It was GeoCities at the time. Anyone remembers GeoCities? Yeah. It was GeoCities webpage. We used to publish them online or email them out to friends. So, and we would build little things like oscillators and filters and various bits and pieces. From there I got the bug quite badly. I started building a modular synthesizer using bits of my own designs and bits of other people's designs, or taking a bit of someone else's design and little bending it a bit, working out how it worked and how it did what it wanted, what it did, and how I could make it do what I wanted it to make. Sorry, it was interesting. Some things worked, some things the magic smoke escaped and needed a little bit of fire extinguisher, but that's part of the fun with electronics. After building a modular synthesizer, I got appendicitis, acute appendicitis, which laid me off work for about 3 months. So in that time I built this thing. I built a prototype of this called the Monowave. I've long had an obsession with a synthesizer called a PPG, which has an interesting combination of sound generation. It has digital oscillators. These are not software, these are digital, these are logic gates turning on and off. Then it has analog filters to give it a nice sort of warm sound and quite a smooth sound to it. And it was one of those sounds that I really liked. It was classically used in the 80s. How many of you remember Gary Newman's Berserker album? Yeah, it was all over that. Other fans, who else used it? Depeche Mode used it quite a lot. Frankie Goes to Hollywood was another one. The infamous bass sound on Two Tribes is a PPG sample. And I've long had an obsession with the sound, so I thought, I kind of want to make one because I can't afford one. So I make this little monophonic version. So I've got 2 oscillators in here with 256 waveforms in each. There is a 24 dB low pass ladder filter in here and a couple of envelope generators. So it's quite a basic, very simple synthesizer. I showed it to a couple of people at a PPG event and they said, "Can I buy one?" So I thought, alright, so I had to go out making some. And I sold 30 in total in a year, with no promotion or anything else, and making them in my spare bedroom in my spare time. It was interesting in many ways. There is nearly 1,500 solder joints in each one of these, each one of which I did by hand. It would take about 2 weeks of my spare time to build one. I sold them for £550, each one cost me £450 in parts. They now, however, on eBay, when they crop up, fetch about £1,100, £1,200. So they've become a bit of a cult classic, which is kind of nice. It gives me a nice warm fuzzy feeling. There's a couple of famous people out there with them. Probably the most notable one is, do you remember the Kerncraft 3000 single, whatever it was? Yep, he's got one of those. He's got pictures of his studio in it, and I quite show pictures. Look, there's theirs. It stands out because it's blue. This is one of the early prototypes. The other ones are a much brighter, more vivid blue, so they stand out in a rack full of black stuff, which is kind of boring. There's this great big blue box. They're really easy to spot, which I love. I had a go at building a polysynth, and to be honest, after building 30 of these with 1,500 solder joints, I kind of got sick of electronics. So I took a break for about 5 or 6 years. Thought, no, I've had enough, I'm not going to do it again. Sold all my books, sold most of my electronics, and even sold one of these. So I still have the original prototype, which I couldn't bring because if you turn it up, it sort of bits fall out. About, I don't know how long ago it was. That was 2002 to 2006. About 2008, I kind of got the bug again. I wanted to build myself a synthesizer. Now, knowing what I do about synthesizers, first thing I needed was a keyboard to play them with, and I didn't have one. So I thought, I'll build myself a little sequencer. Now, a sequencer is a thing that basically, think of it as a bit like a piano roll. It'll play one note at a time in a sequence and then just keep repeating them. Very simple. So I built this thing called Gorf, which is this little box here. It's very simple. If I press play, it's just upside down, which is this one. You can hear it stepping through the sequence and playing the notes. And you can, it's upside down, you can change the notes it plays. Like that. It doesn't have to be musical, of course. So I built that as a test tool. Now,
is it making MIDI? Is that how it's working?
Yep, this is transmitting MIDI. For me, the easiest way of getting into synthesizers was MIDI. CV and gate has its place, and I like it, and I think it's great, but it's not as flexible, I don't think, as MIDI. There's a lot more you can do with MIDI, but we'll come back to that because I have an interesting slant on analog versus digital. So I built that as a test tool. Now somebody said to me, why don't you enter it into this contest to win this weird guitar called a Zoibar, which was a bit of metal with some strings on it. I thought, yeah, go on, why not? And I won. Much to my surprise, it's the second thing I've ever won in my life. I was really quite chuffed. And then the people started saying, well, can I buy one? Can I buy one? So I thought, I'm not going back to soldering these joints again. So I started selling them as kits. And you could buy like the basic PCB with a pre-programmed chip, switches and the knobs. And they kind of flew out the door. Then people said, well, can I buy one pre-assembled? I thought, I'm not going back there. So I got in touch with a friend, and he did some digging around, and we found a community workspace in, I think it was the Netherlands. It was government sponsored, and for every 10 euros I gave them, the government gave them 15 euros. Great, so they were getting paid 25 euros an hour and they would build these things for me for 10 euros. So I sold, since then I've sold about 400 of those in the last sort of 3.5, 4 years. So it's been quite good for a test tool. It's done remarkably well. There is, on my sort of design shelf, there's a modular version of that to go into a modular synthesizer which has to have CV and gate outputs on it. Because that was another thing. People said, oh, can I have CV and gate outputs? Like, not really a lot of space left in this little box. So I made a bigger version that goes into a standard rack mount. I haven't productionised it yet. So I did that. Then I thought, oh, when was this? It's back in 2000. I wanted to build myself a polyphonic synthesizer. Considered the holy grail of synth DIYs, because monosynths are relatively simple. You build one circuit, it works great. If you want to build a polysynth, you've got to build 8 or 10 or 16 of them that are all the same, stay in tune, synchronise and work at the same time. It's quite a difficult thing to do. So I bought from Korg a load of their filter chips that they were selling off because they just didn't care anymore. They were like £4 a go. So I bought, I think, about 30 of them. And then I thought, I built myself a polysynth. It would be great, and I'll use this and I'll use it. And I never did. So then I thought, I've got all those chips sitting there. This is about 2 years ago. I've got all those chips sitting there. I wonder how small I could make a monophonic synthesizer. So this was the monophonic synthesizer that I made. And this has almost the same feature set as this. So it's quite a bit smaller. It does sound a little bit different because it has a different filter in there. But it runs off of a 9-volt thing instead of a mains lead. And it's a little bit lighter than this lump of steel. This is 2mm stuff called Zintex, which is a mix of zinc and steel. It's quite a lump. These are sort of pocket-sized. You can plug a stereo lead in, your MIDI and your power, a sequencer or a keyboard, and you're off. I've made other variants of them since. This one is called Tron. This is a little drum pattern programmer. So for those of you who like drum machines and stuff, great. You can program your own little drums. I got that because I bought an 808 clone from MFB, which sounds great, but the sequencer on it is just, I don't know who wrote it, but it's a nightmare to try and use. So I wrote this because it's nice and simple to use. Then I thought, well, if I'm going to make a drum pattern programmer, I need to make a drum brain. So I have this little thing which I've made. You can tell it's a prototype, there's lots of wires on the back. And that's actually running, what's playing the sounds from a Linn drum from the early 80s. So if you listen to probably Human League records, you'll hear it all over it. And that's playing 8 of them at the same time. So it's a little bit smaller than a Linn drum now as well. So this is where I got to. So I got to this stage, I've got all these little things out there and they're selling quite well, sort of 400, 450 of them over the last couple of years. It's quite nice. It's very satisfying and very rewarding, but I want to do a little bit more, I want to go a little bit further. So I met, back in 2000, 2001, when I was making these, a chap called Philip Tayson. Now, if you Google his name, he's well known for lots of things. One of the things he's well known for is an insane synthesizer collection. You name any synthesizer in the world, he had at least one, probably 3. Things like Gleeman Pentaphonic Clear, an MS-20 Blackboard, which was an MS-20 on a thing this big, that flat, designed so they could teach how to use synthesizers in schools in Japan. I think there was only 50 ever made. He had one. He was that much of a synth nut. So he bought one of these, and we became good friends. And then last year he got in touch again after he moved on and done various bits and pieces, and he bought one of these little sequencers and one of these little synthesizers. And he said, you know what, why don't we have a go at building a synthesizer? And I thought, yeah, I'm kind of bored of my job, and I got to that stage in my life where I could do the job I did and I kind of enjoyed it, but it wasn't fulfilling. So I said, okay, let's have a chat. And we had a long conversation over many months, and eventually we agreed to try and build a synthesizer. Now, we did talk about this about 12 years ago when he bought one of these, but at the time everybody was switching to soft synths. Everybody was going from piles and piles of gear down to laptop. A lot easier to gig with, You know, a bit more easy to keep through customs, you don't have to pay heavy shipping bills, and you don't break your back lifting it. And soft synths are great for that, but I don't think they have quite the edge sonically that you can get from hardware. Now, there are people that will disagree, and that's fine. One of the things I love about synthesizers and music is that there is so much variety out there that there isn't a right or wrong answer to anything. Everyone has their own personal preferences. I like hardware synthesizers, always have done, always will. So we got talking and he said, you know what, let's do some research. So we did some research. And the synthesizer industry has grown 10% every year for the last 4 years in hardware. So it is a growing market again. People are buying hardware because, personally, I think part of the problem is software isn't particularly reliable. You can buy a software synthesizer and it can be great. Then you get your operating system upgrade and all of a sudden it doesn't work anymore. The hardware, it doesn't matter. As long as you've got power in and audio out, it works. So there's a nice simplicity to having a piece of hardware. So we got talking, and originally we were going to build a mono synthesizer. Little monophonic thing, try and get in, and we built one and we had the prototype working. Like, yeah, this is really good. And then we said, you know what, it's only a hop, a skip and a jump to turn this into a polyphonic synthesizer. And then life got really complicated. So we both thought this was a fantastic idea, and we set off merrily down this road of building a polysynth. And yeah, it's been a very, very complicated journey. We're not there yet. We are due to release in July. I can't talk a lot about it because there are some bits and pieces in there we are hoping to patent. But I can tell you it is, if you imagine 8 of these, or sorry, a number of these, more than 8, in a box, with a few steroids and a few extra bits and pieces and little twists bolted in, you're going to get close to what we're doing. It's big, it's brash, and it sounds wonderful, I have to say. I've always wanted to build a polyphonic synthesizer, and this is a dream come true. To be able to do this, and do it with someone who's as passionate about synthesizers as I am. My business partner Philip is mad on synthesizers. We both, you know, the whole market, the software synthesizers, the hardware and the DSP and something are great, but we have this mad passion for hardware, and we are both very passionate about it. And the synthesizer we are building is designed and manufactured and assembled in Britain. There hasn't been a British synthesizer since the Oscar, so it's 25 odd years. So fingers crossed, people will buy it. Otherwise, I'll have to go back to my boring day job. What else to talk about? So that, in a nutshell, is about where I've got from doing things as a hobby to doing things as a professional career. So I'm now doing this full time. I've been full time since the beginning of February.
Could you tell us why is it difficult to go from the mono to the poly?
Yeah.
Is it the way the software has to constantly shift between the different modules within your box of kit?
Yeah.
Or is it something else?
There's a number of things. If you imagine a monophonic synthesizer as a person singing, every person has their own vibrato. Typically on a synthesizer, if you play a vibrato, you want them all in time. So if you've got 8 people standing there playing a chord and singing, how do you get them all to sing in time? So yeah, a large portion of it is the timing of things, getting the bits synchronized across all of the voices. Also, the data in here, when you're moving the data around to turn a note on, is 3 bytes. Great. When you're playing with the synthesizer, you've got 8 or 10 or 16 times that number of bytes to move around. So all of a sudden you've got to start worrying about bus speeds and latency. And then you get onto problems like, well, how do I ensure that if I'm using an analog filter, how do I ensure they stay in tune? So it goes from being quite simple to all of a sudden exponentially more complicated. There are lots of nuances that you don't realise. So one of the other problems is analog electronics gets warm. One voice on its own, not too bad. 16 or 12 of them in a box, yeah, you start getting heat problems. You know, things start getting warm, you have to make sure you've got enough ventilation around. Power supply becomes another problem. nobody makes analog power supplies anymore. Everybody's making power supplies for computers. So finding a power supply that will give equal amounts of positive and negative voltage is really hard. That was one of our stumbling blocks for a long time. But if I was doing one voice, I could pick any power supply off the shelf almost. So it has proven quite a challenge. So
there's the right way to understand it. It's just basically you said 8 and you said 12, so I'm guessing you're making 12 channels. So if you've got a keyboard, you can hit as many as 12 keys at once, and then you hit the 13th key, you're shit out of luck.
yeah, basically it goes quiet.
So then what you're really doing is you're doing one of them, but you're doing 12 of them.
Yeah, I mean,
what you're saying is there's different challenges of keeping them all in sync in terms of frequency and
it's
stuff.
in free, so if
But presumably all those controls, effectively you got to an analog of 12 of them all at once.
yeah,
So you have to make it a bit more.
yeah, and this little thing. So, for example, in this one, it doesn't have any patch memory.
Yeah.
So, what you set the knobs at when you turn it off is what it comes on at. If I find a great sound on there, then I want to have a great bass sound. I can't have both. With a polyphonic synthesizer, it's not acceptable for the customers because people want to be able to go, I want a string sound, I want a choir sound, I want a piano sound.
So your boxes can have some software in it after all.
It's going to have a lot of software in it.
So
It
it's
has
a
an
hybrid,
awful lot
right?
of
It's
software
not
in it.
really just that.
No. So I'll explain a bit about that in a second. But yeah, so there is a lot of software in there. So, for example, these are all pots. So the filter cutoff on here sends a voltage straight into the filter. On what we're doing now, there's a rotary encoder which goes through a processor, which changes to a DAC and changes it. So again, if I've got 12, 16, however many voices inside my box, I've got to get that data to all of them. And then there's little things like, if I'm going to make a polyphonic synthesizer and I set the filter cutoff so it's quite a bright sound, do I have one voltage across all of the voices? Or do I have eight voltages? The advantage of going for 8 voltages, it means I can then make it multi-timbral. So I can have 8 different sounds playing at the same time. But that also means I've now got 8 times the number of DACs. So I've got 8 times the amount of processing required to turn that DAC on and change the voltage on.
But also make controls.
Yeah. So there's a lot of trade-offs when you're going from a monosynth to a polysynth. And it can be simple things like heat, it can be simple things like timing. But then when you start thinking about how would I use it, it's quite a common one is you'd have a bass sound on the left hand and a choir sound or a string sound on the right hand. Unless you design it properly from the start, you can't do that.
With a control per voice, you could have pitch following on a filter as well, which you could have a single voltage for all the channels you couldn't do.
Yeah, there's lots of little nuances along the lines that you've got to think through. And you could have one, for example, you could do DW8000 has one control voltage for the filter cutoff, but then it's got 8 voltages for each of the things for the notes, so you can have note follow. So they got away with 9 DACs instead of 16. But that's a compromise again because it's still not truly multi-timbral. Sorry.
For those who don't sort of understand much of this, could you draw us a sort of diagram, a little block diagram, so we've got the bits of the how it fits together?
Yes. Yeah.
Okay, so who knows what a synthesizer is? Okay, right. Who knows what music is? No. Synthesizer. Sorry?
That was a harder question.
Yeah, that was a harder question. So most of you will remember stuff from the 80s, I'm fairly sure, and a few of you from the 70s and the 60s. So if you think back to, let's pick one, Keith Emerson of Emerson, Lake and Palmer. You must have all heard of him. Famous for using a huge, great big synthesizer, which they've just rebuilt. It would be nice to have $96,000 to spend on that synthesizer.
Is that the move?
Yeah. So there are some key players in this.
Joke.
Very good. I didn't spot that one. You can tell it's been a long day. Bob Moog was one of the first people to commercialise the synthesizer, shall we say. He built modular synthesizers, like Keith Emerson's one, which was great for Keith Emerson when you've got a whole stack of roadies behind you, but for the average touring musician it's a bit much to carry around. He was most famous for making a thing called the Mini Moog, which took various parts from his modular and put them in a little 3 octave, 2.5 octave keyboard, 3 oscillators, a filter, and envelope. Quite simple monophonic synthesizer, and it was an overnight success. It sold hundreds and hundreds of the things. notorious for having lots of problems, and I have to say, I know I'm on camera, it's not my favourite synthesizer. And I regularly get chastised for saying that. The one I'm building at the moment. Good question. No, I like the Mini Moog. It has a certain sound, but for me, it's not the most flexible sound out there. There was another chap called Alan Perlman who built ARP, who made some stunning synthesizers, the Odyssey, which is one I rate well and truly above the Mini Moog. It has stable VCOs, so when you switch it on, it stays in tune. Something that I don't think the Moog achieved until about the third or fourth revision. It has a great sounding filter. It's just a monstrous synthesizer. You have people like Tom Oberheim, who made a little synthesizer in a box called a SEM. I forget what it stands for now. Anybody remember?
Can't remember.
No.
Been reissued again now?
Yeah, but they've been reissued again as well now, because people are going back into buying hardware and have realised if you want a big fat sound, you've got to have a chunk of hardware. So let's explain the basic parts of a synthesizer. There are, in a synthesizer, there's probably half a dozen simple parts, and then you can get all complicated, you can add on lots of bolts and whistles, like anything. So, and probably the first part to talk about is a thing called the oscillator. So let's draw an oscillator. Alright, oscillator here. This thing generates a waveform. Typically, you will get a sawtooth out of it, so the voltage will go up and then suddenly drop and go up and drop and up and drop. Called a sawtooth because it looks a bit like a sawtooth. Most of them will also have a square wave output. Quite a few will have a triangle. Only a few actually have a sine wave. So getting a sine wave out of analog electronics is quite a complicated process. Getting a sawtooth is easy. You have an integrator with a reset capacitor, so basically you charge up to a voltage, and when you get to a point you reset it, short it out and it starts again. Very simple circuit to do. I remember building my first oscillator when I was about 16 on my kitchen table, much to my mum's annoyance.
So the keyboard sets the frequency of that?
Yeah. So you would have typically here a keyboard, excuse my bad drawing, and I will probably not get the right number of black and white ones, but there we go. And that will send a voltage into there that says play me a middle C, play me a G, play me an F. And this is the basics of your synthesizer. Typically then, what you get out of here, if you have a sawtooth, is a very bright sound, lots of rich harmonics, which is great if you want a nice big brassy sound, but if you want something a bit more subtle, it's a bit too much in your face. So typically this will go into a thing called a filter, or a VCF, a voltage controlled filter. There are hundreds of designs of filter out there, lots of different configurations, they all sound slightly different, they all do different things. In its essence, for a simplest one, you have a low pass filter, which I'm sure most of you are familiar with. And again, you have a voltage in that sets what's called the cutoff, which is this point here, a point at which it starts dropping off. And out of it you get another sound, which is typically, if you take your sawtooth in, you can set the cutoff to sort of 5 or 6 kilohertz, and it starts to drop off sounds after that. So you get your sawtooth is no longer so bright, so in your face, but it's still got those extra harmonics. The last bit now, of course, this is all quite boring because you press a note and it makes a sound and keeps going forever until you press another note and does the same thing. So the last bit, a very basic one, is a VCA, a voltage controlled amplifier. Somebody's chucking at the back there. So at this point I need to go back to the keyboard and say, when you press a note, typically you get 2 signals out of the keyboard. One is what the note is, and one is I've pressed a key. One's called the control voltage and one's called the gate. And in a very simple one, the gate connects to the VCA so that when you press a key, you get the sound. When you let go of the key, you don't get the sound. Very simple. That's probably the 4 essential parts of a synthesizer. From here you can add in a myriad of things. Probably the most common thing to add in is a thing called an envelope generator. So So when you press the key, you will take this voltage and go in here. And when you press the key, the thing will start here. It will rise slowly while you hold the key. Then it will drop to a level, hold while you hold the key, and when you let go, it will fade off gradually. So if you have typically a sort of string sound, they come in quite softly, so you would have quite a long time set to this attack. It would come in, and then when you let go, it would gently fade out. So you have what's called attack, decay, sustain, and release. It's the most common type of envelope you can find in the world. The Mini Moog, you didn't bother with this bit. You had attack and release, or attack and decay, because it saved a whole pile of circuitry, basically. Kept it
so typically knobs are you on the top there to set that?
Yep.
Yeah, thank you.
Typically these are brought out to knobs on the front. On this one, they are A, D, S and R. I'll plug this in a second and I'll show you what the difference is the sound makes. This also then usually goes into the filter and changes the cut-off, so you can make the sound sort of brighten and darken as you play the notes. Quite often you will have a second ADSR, which is linked to the same gate, and that will go to that, and you lose that at that point. So that now you can fade the note in when you press it, and when you let go it can fade out, volume-wise. That's how you can do it on the volume, and you can do it on the sort of tone and timbre of the sound. Then you can add in things like, oh, well, let's make it a bit more interesting, we'll have a second oscillator in. So now we've got two oscillators, and I could have one with a sawtooth, one with a square wave. I could have them set an octave apart or tuned at a fifth apart. All of a sudden I've now got a lot more richness to my sound. And you can add in as many of these as you want. One of the good places to start if you want to play with synthesizers is Nord used to, and I don't know if they still do. Is it Nord? No. Yes it is, I think. They did a software synthesizer in a rack. They released a free version of the synthesizer. You could play a few notes, and it had some very basic modules. But you could play with them on the screen, you could get an oscillator, get a filter, you could wire them together and play it on a keyboard, or play it from a MIDI song or something like that. So you could have a quick play and get a feel for it. Another way to do it is to get into modular synthesizers, where you buy an oscillator module, you put it in your rack, and then you buy a filter module, you pop it in your rack, and you connect a cable between the two. And you go, well, that's very addictive. That will cost you several £1,000s and possibly a divorce. There are people I know who have walls full of modular synthesizer. Because once you get the hang of this and you start playing things, you go, well, what would happen if I took the output of this and fed it into the pitch of that? Or I took the output of this and fed it into the controller input voltage of that. And you can start doing all,
if you're doing that, that's monophonic. It's really hard to do that in a polyphonic way.
Yeah.
like not possible.
Well, it depends. So the problem with doing this, so this is a monophonic way, it's quite simple. As soon as you start talking about putting presets and control in, all of a sudden you start needing these things called VCAs. So if I want to change the volume of the mix between them, I need two VCAs. Whereas before I just had two knobs. Similarly here, if I want to change the depth of this, all of a sudden I need a VCA. And all of a sudden you find your nice simple design that's got hundreds of VCAs all over it. Probably one of the other most common ones is an LFO. This is an oscillator that goes slowly. So if you think about a violinist playing a violin, they'll wobble the note. Usually it's around 7 Hz. I don't know why it's around 7 Hz. I think it's something to do with the time it takes to get from there to the ear or something. This typically will control the pitch of the oscillators, but it can also control the pitch of the VCF and the VCA. Great, nice and flexible. Oh, hang on, I've just added 4 more VCAs to my synth design. So yeah, all of a sudden I'm now up to 8 VCAs before I've even started doing anything clever. It's very easy to get very carried away. And one of the things we have to do when you're designing synthesizers is say, right, these are the things I must have, these are the things I would like to have, and these would be, dreams come true. So you start off here and you go, yeah, I'm going to do this and I'm going to do this, and then you go and think, hang on, my circuit board's going to be this big. So you think, right, I'll redesign it, and you cut back on some of the things, and it gets a bit smaller, and it gets a bit smaller. So it's different. This is where some of the advantages between software and hardware become apparent. There are, I'll talk about this, several different types of synthesis. There is what I call DSP. This is basically digital signal processing. I'll probably get bored of writing by the end of it. This is making a sine wave or making a sawtooth using pure maths. It's done in programming. Typically they're done on chips that are optimised for doing maths, called digital signal processors. There's a couple of variants out there. They're very high speed, they're very clever, and you can get, so if you've ever heard of a thing called the Access virus, great big synthesizer, 120 voices of polyphony, lots of clever things, it's on one chip that big. So from a hardware side, you know, it's wonderful to make, manufacture, because it's so cheap. From a software side, you've really, really got to know your maths to do it any justice. And to get the best out of them, you have to do it in assembly language as well. So, not high level like C, because C isn't quick enough. With DSP, I have got another synthesizer called Phoenix and one called Monowave 2, which I wrote as in a DSP. You can do lots of clever things, but there's little things like when you multiply a number, you can also move two locations in memory at the same time on the same clock cycle, which no C compiler in the world can allow for that sort of optimization. So you end up with reams and reams of assembly language. So it's great, it's really flexible, hardware-wise, it's really cheap, but you've got to be a maths genius to work it out. I can dabble with it, I wouldn't call myself a genius. Then there is analog. I'm going to spell it the English way. This is where you have, so there are two parts to this. There are analog oscillators. These are, to me, things that you generate the frequency in the waveform using a voltage or a current. So typically you would use a capacitor to charge, the voltage would rise and then you'd reset it. That to me is an analog oscillator. I'll come on to the other variants in a moment. Then you have an analog filter, typically made with a couple of, if you take the ladder filter in here, it's made with 10 transistors, some various stages in between. You drop the voltage across the transistors and it changes effectively their resistance. So you're changing effectively an RC current ratio, so you get your filter. So yes, analog oscillators, also called VCOs, and you get analog filters, analog filter, called VCFs. Then you have some hybrids. You have a DCO. This is some synthesizers that were famous for this before people get it sounds horrible. Roland down for Junos, the Roland Junos, JX-AP, JX-10 were all fantastic synthesizers of their time, very popular, and they all use DCOs. People still love the sound and still want them, but they say, oh, digital sounds horrible. These basically have a circuit that starts at voltage and rises. And that's it. It doesn't ever get reset. What they have then is they've got a microprocessor that sits above it and says, well, when it gets there, I'll drop it, and that will give me a 440 Hz A. Or when the next note you play, it will say, I'll let it get there and then I'll change that, which will give you a note that's a bit faster. So the downside is you get an amplitude that changes, but for very little electronics, you can get quite a powerful polyphonic synthesizer. A little microprocessor and a little op amp with a capacitor. It's very few parts. Downside is you can only get that and a square wave out of it. Getting anything more complicated requires a whole bundle of extra circuits. So if you look at the Roland Juno series and the JXs, they've basically got two waves, sawtooth and a square wave.
So does that mean the frequency is stable based on how good the microprocessor is rather than voltage?
Yep. And that's why they don't go out of tune. These typically, the processors are running at 8 megahertz. certainly in the older ones.
Sounds like a Z80.
Some 6800s or 6500s, but yeah, not too far off.
502.
Yep. And they'll basically just be using that, monitoring the voltage and setting a trigger point. Then we have digital. So this is where I talk about things like, so hang on, if I put in here, this is Juno stroke JX. This is Minimoog. This is, I've got the virus in there.
Where does the Casio VL take my
What about the Rolf Harris thing with the PCB keyboard?
So that was actually a VCO. It's a very simple VCO. I got one when I was like 10. I think
That was my first synthesizer.
Then, if you've got one of the original ones in the box, they're now worth a fortune on eBay. Yeah, they're now several £100 on eBay. I don't know why. But that was actually a VCO, so that was analog. Didn't have a filter, didn't have anything clever, just played a note. The Casio VL tones were digital, so they used quite a lot of the time custom silicon. They'd roll their own VLSI chip. These days you do it in an FPGA or something, which is a little bit cheaper and a bit more affordable, unless you have to have £100,000 around to roll your own silicon. And they basically, it's logic. So if you're familiar with Boolean logic, where you've got AND gates and AND gates, OR gates, all that kind of thing, it's that. You've got memory, you have a thing that counts. Basically, the simplest form, so the monowave uses digital oscillators. I have a bit in there that's just an oscillator, and it's just kicking out a square wave, nothing else. That drives a counter, so I get my 0, 1, bit 1, bit 2, bit 3, bit 4, so I can go from 0 to 255. That then drives an EEPROM, in the case of the monowave, which then drives a DAC, which gives me my nice sine wave or sawtooth or whatever.
So EEPROM stores the waveforms.
Yep, the EEPROM stores the waveforms.
You just clock out all you want.
Yep, and all I've got on that one basically is I've got another bit of logic. It's a latch, I forget which one.
So it increase the frequency, just clocks it out faster.
This is basically just an adjustable clock.
If you play like an A and then a B.
Yep. This rate here changes.
Yeah.
This is running at its full speed. I think it's about 1.2 megahertz.
What actually sets the frequency of that clock? How are you
That's-
controlling that?
There's another microprocessor that's controlling it. I did look at all clever sort of micro timers and all sorts of things, and to be honest, I ended up using a little microprocessor for this. A tiny little one with like, I think it's 512 bytes of flash memory, and basically you just send it a code and it toggles a pin. That to me are the 4 types of.
So in that last one, do you still have analog downstream?
Yep.
VCF, the VCA?
Yeah. You still got analog.
Yeah, so it's just the initial.
So you
core
can have,
VCA.
so in the case of the VL tones, this EEPROM was probably quite big and would include the ability for this thing here to change the waveform as it went through time.
Yeah.
So you would get the thing fade in and fade out. But it would only ever, no filter or anything, it would just had a single DAC output. That's
So
quite
that
cool.
one you would only have the voices that were in the EEPROM, right?
Yep, you're stuck with what's in there, which is quite common from memory from the VL tones. I think that's what they had.
It's not really a synthesizer, is it?
I would argue not, but who am I to judge? Everybody has their own idea about what a synthesizer is. For me, it's what I'm building at the moment. For some people, it's this wall full of knobs and wires that they call a modular. And for some people, it's the stuff on the laptop. As far as I'm concerned, as long as it makes a sound that you like, it's all good. There is a huge resurgence in this thing called a VCO in the analog. I like analog oscillators, but the circuit to make an analog oscillator is so complicated. One of the reasons it's complicated and difficult to make VCOs is the way the human ear hears pitch. you hear pitch logarithmically. So when you go up an octave, it's double the frequency. And you go down an octave, it's half the frequency. Analog electronics doesn't work like that. So you end up, if I go from 1 volt to 2 volts to 3 volts, on a normal oscillator, it just goes up incrementally, it doesn't double. So you have to use a transistor, and you have to sort of slightly abuse it. So transistors have a transfer function. I'm probably going to draw this the wrong way around, and I'm sure Ray will correct me if I do, which looks a bit like that.
I can't remember that all.
Tim certainly will.
Exponential curve, all you need.
Yeah, So where this tends to operate is around here, which is the bit of the curve which is logarithmic. So that's how you get from a linear control voltage to a logarithmic pitch. The downside is transistors, you only have to blow on them and that resistance changes. So one of the problems the early Minimogs faced was when you've got, I don't know how many transistors there were in the original ones, but in the oscillators I think there was about 6 or 7 per oscillator, and you've got 3. How do you make sure they're all in tune at the same time? Given they're, if on the circuit board they're there and there, so the top one's going to get heated by the bottom 2. So there are lots of complications around making an analog oscillator. Just realised to draw that there. That's there.
Which was the synth that Jar had that was renowned for going out of tune?
Oh, I don't know. Pick one with analog oscillators.
Yeah.
Probably lots of them.
Lots of them. I mean, a lot of the early synthesizers did. One of the things that ARP did, or Alan Perlman did, was he put his in little bricks. So he got a potting compound and put them in there because it made them a bit more immune to the temperature.
Couldn't fix them though, could you?
No, you couldn't. As soon as you started chipping away the compound, all of a sudden a transistor flew across the room. One of the things that Moog did to fix his in his later one was they had custom transistors. I can't remember what they were called. UA721? Is that the one?
Oh, right, yeah, the Mac pair.
Is it 721 and 723?
726, isn't it?
726, that's it. So it was basically a pair of transistors in a can.
With a heater in it.
Yeah. And to make sure it wasn't susceptible to changes at room temperature, they basically put a heater in it.
It's like a crystal.
In a clock.
Yeah.
In a little metal can, and basically it heated that to above room temperature. So it didn't matter then if you blew on it or the wind door opened, because it was in a can and it was being heated to 40 degrees or something like that. So there's lots of cunning tricks you can do around to get around these problems. But essentially one of the biggest problems with an analog oscillator is it will never be in tune. Which some people like, that gives it character. Digital oscillators are always in tune, unless you don't want them to be. And that's my argument. I can make a digital oscillator sound analog, just by a little bit of jiggery pokery in the microprocessor that's controlling it.
With the software ones, you were saying there's a problem with sort of synchronising all these lots of gates. What sort of precision do you need in order to sort of get around it? How fast does it have to go before that problem goes away?
Luckily, humans are really slow, which is really good. So computers these days are so fast, it's insane. But human hearing is actually quite slow. And so is human eyesight. The good one is the multiplexing of LEDs, if you've come across that, where this, for example, there are only ever 4 LEDs on at the same time on this. But I'm updating them 2,000 times a second, so you can't see that one's flickering. It's much the same with audio. To be honest, I would say if you refreshed audio stuff less than about 4 kilohertz, you can notice it. Typically, do you remember when I drew the envelope generator and you have it going up like this and coming down like that? If you have a slow rate, you can get stepping. And that, if you're in the wrong situation with the wrong setup and the wrong parameters, you can hear it stepping. So you need to ensure you've not only got a high enough resolution, but you're also updating frequently enough to get the bits in between so that you can't hear the stepping. And again, there's lots of tricks you can play with capacitors to smooth it and all sorts of
The
things.
steps for smoothing isn't the problem, it's the frustrating combination of the two that's the problem.
And like I say, it's all about trade-offs when you're designing a synthesizer. There is no right and wrong way. The Minimoog Voyager, if you ever open one, You know it's in a keyboard this big. The circuit board inside is that big. It's full of analog electronics. You know, that's 2 oscillators, that's a filter, that's 2 envelopes, an LFO, MIDI, everything else. It's not a pure analog synthesizer, but you know, it's small. I can carry that in my pocket. There's no way I'm going to fit one of the new mini Voyagers in my pocket, not without giving myself a hernia anyway. So there's lots of pros and cons to all the different ways of doing it. I dabbled with DSP, I dabbled with analog, but I just don't have the patience with DCOs. The other thing I like about digital is I can put lots and lots of waveforms in there. So the monowave's got 256 waveforms. With analog, I'm stuck with a sawtooth, a square wave or a triangle wave, and a combination thereof. So for me, the digital oscillator gives me a lot more flexibility. But analog filters still sound better than digital filters. There's just something inherently more. I don't know. I think.
So that was my question about speed.
Yeah.
And it surprises me that if you can do gigahertz, you know, on a Raspberry Pi, well not quite, but no, on a megahertz on a Raspberry Pi, why that could not be as good as an analog? That's curious.
So there's a lot to do with. So for DSP, without getting too complicated, there's a thing called Nyquist theorem. Have you ever heard of that? So your CD is recorded at 44.1 kilohertz because somebody way back when decided that human ears couldn't hear much above 18 or 19, so if they set the sample rate at 20 kilohertz, you'd never know. Doesn't quite work like that. The problem you have with DSP synths and software synthesizers, and they all have to adhere to this, is they have a fixed sample rate. So they will update their outputs at 44.1 kilohertz. What this means is, if I've got a nice sharp sawtooth, I can't have that harmonic if I go above about 6 kilohertz, because it's too much for the DAC to handle. So instead of a nice sharp sawtooth, what I get is a sort of a bit of a flumpy sawtooth. So I start to lose some of the richness in the sound.
But why not just up the speed by 10 times? Because if you got into megahertz, that would...
But how far do you go? So there are various standards for audio. What's considered high end is 192 kilohertz sample rate at 24 bits of resolution. There are some fantastic videos on YouTube of people explaining why that's pointless. I can never remember his name, but he's so funny when he describes it. And you sit there and you go, damn, that's really good. I can never remember how he does it. In theory, yes, you could go up to megahertz and megahertz and megahertz. But then you've got to remember, you've got to do all that math in that time. So typically, for example, the virus, I think the TI's got 2 DSPs in it. If I'm generating a waveform, I'm filtering it, I'm generating 3 envelopes, 3 LFOs, a couple of different types of filters and stuff. I've only got so many clock cycles in between to squeeze all that in.
Things like the Raspberry Pi, they would do all that in parallel on the video card, don't they? On the video.
Yeah, these days things like some of the video cards and number crunchers are getting really quite powerful. And I don't doubt at some point some of the synthesizers that will come out from that will sound phenomenal. But one of the problems is, I have a friend who made an oscillator, a VCO, and it didn't drift. Like something like 0.0001% drift per hour. And he was very proud because it was a big circuit and it was rock solid, and people hated it because it sounded digital. It had no character, it had no warmth.
Control voltage.
Well, isn't the character all the inherent human failing?
Yeah.
Kind of the bad playing. The digital is too perfect.
That's exactly.
You can't hear.
Yeah.
Put some bugs in.
Yeah. And I did just that. So I built a synthesizer called the Phoenix, which was a DSP one on the same processor as the virus used, and the filter sounded really, really sterile. It was too perfect. So I broke it. I intentionally went in and I mismatched the 4 stages of the air filter, just so it would give it some character. And it totally transformed the sound of the synthesizer. And I think that's the problem. Programmers aim for perfection. Musicians don't want perfection. Musicians want character and warmth.
Instruments don't play at perfect frequency,
Correct.
and they're infinitely variable. Whereas the digital is fixed, and we don't like that.
But there are So for the gigging musician, I've played lots of gigs in my life. One thing I like is when I go on stage with my band, if I press a piano sound, I want a piano sound and I want it to stay in tune every night. With analogue, I'm not going to get that. Even with a piano, if I turn up at a gig, either I've got to bring my own piano or pray to God that the piano's in tune when I get there. So there are advantages to the digital stuff. The fact that it's portable, it's small, it's repeatable, are really big bonuses. But yes, you're right. If it's programmed perfectly, it can become a bit soulless. And I think that's one of the things people are starting to realise with synthesizers, is aiming for perfection is great, but you don't always want it. You know, my wife, and bless her, she would kill me for saying this. She crochets scarves and jumpers and things. And she'll hold it up and say, oh, I'm really fed up with that. And I'll look at it and go, oh, it's beautiful. She said, but there's a stitch done wrong there. It looks wonderful to me. She'll unpick it all and me do it. A lot of people want perfection, but I don't think they realise when they get it what they necessarily want is something that's perfect, but with a sort of a bit of a fuzzy edge to it. So, the synthesizer I'm building is a hybrid, so I have digital oscillators and I have analog filters in it. Again, because I want the stability, the repeatability, and I want the flexibility of having several waveforms. But I want the warmth I can get from an analog filter that I can't get from a digital filter or a DSP filter. And the boards inside it are that big, but they are all surface mount. So I am not soldering them. There is a machine somewhere in Wareham that's soldering them for me. So there are, I think one of the problems we've had, if I go back to the synthesizer a bit, if you play guitar or you play violin, if you want an instrument, you can go to a shop and you can spend thousands of pounds and buy yourself a stunning guitar from PRS or one of the other many fantastic luthiers out there. Same with the violins, you can buy a violin for thousands of pounds and it will sound different to the one you buy from Argos for 80 quid. With synthesizers, that's gone. When I grew up in the 80s, they were big things, they were great, they looked stunning, they felt like instruments. Now they all feel a bit plasticky and a bit cheap, which is great because it's bringing them to everybody who wants to play a synthesizer. You know, now my grandson can go and pick up a Korg mono or monotride for 50, 60 quid, and he can play. I couldn't do that when I was a kid. You know, if I wanted the synthesizer, it was £700 or £800, and that was 2 months' salary. Didn't happen. So it's great for that because it's brought the instrumentation to the masses, and people have been able to make some great music and some terrible music, but some great music. But what's missing is there's nobody doing an instrument. People are making synthesizers, and they're trying to. My business partner uses the phrase democratise. I like the phrase the ubiquitous. People have just taken them as synthesizer as just a thing that sits there in the corner and makes little noises. And they're everywhere, which is good because it gives people the access to music and to the tools to make music. But at the same time, it's cheapened it. There's nobody making in the synthesizer world the PRS, the Stradivarius anymore. So what we're doing is we're bringing that back. So we are aiming at a very, very high-end instrument. The knobs on the front are aluminium. They're turned aluminium. Not plastic. They're not moulded. They're turned aluminium. They happen to be Swiss as well. So, but we've gone to that level of depth. We want it to feel like an instrument because myself and my business partner are both mad about synthesizers feel. That's what's missing. You know, if I say the guitar analogy is the best one I have. I can buy a guitar for 80 quid from Argos. I can go and spend £4 grand on a PRS. One will feel like an instrument, one will feel like a toy. I think that's what's happened to the synthesizer industry.
Time for tea.
Okay, cool.
What sort of keyboard would you put on your new machine?
Keyboard manufacturers are the ways. There is one manufacturer of keyboards left in the world, officially, which is a company called Feitar in Italy. They have been making keyboards for 30, 40 years, no longer than that. They used to make them for church organs in the 1800s. So they've been around a while. You can get them from China. There is a company. Is that video running?
Yeah, you're still talking.
There is another company that shall remain nameless whilst the video is running that's using the Chinese keyboards in their high-end synthesizers. We're using the Fatal mechanism. It's a semi-weighted one. It's got a touch.
It's a nice feel.
It feels. So we have one of the competitors' products to one side, and you can play it, and then you can play ours.
So
And again,
what's using an electric piano or just a MIDI output?
nothing.
Would that not be a perfect solution? Because then you go choose a piano you like the feel of, and then you just...
A lot of people do. A lot of people will have one controller for their studio, which will be an 88-note wooden, fully weighted hammer action keyboard and all the rest of the bits, which is great. And then they'll have modules for making the sounds, which is fantastic. But the problem is it's not really very portable. When you want to take a gig and take it to a gig in a pub and set it up, you've got this fully weighted keyboard that's this big.
So yours will have a restricted size keyboard, but it'll be a keyboard.
And there's nothing to stop if you want to say, well, okay, I still want to use one nice keyboard, so I'll put that on top, plug the MIDI lead
But
in.
you'll still be using MIDI between your keyboard and your thing.
Yeah.
So actually, it's fine.
Yeah, so you can do that if you wish.
We'll get a cup of tea.
What I'll do is I'll show you a couple of things. Somebody was asking about the difference between analog and digital oscillators. I can't remember who it was. I have a demo tune here, which is... Yeah, that was coming. This is played by a friend of mine called Paul Dagan. He's a first-class musician who really knows what he's doing when it comes to a synthesizer. So that was done in one take. And that was done on this actual one, because I bought it off of him. So the oscillators don't sound digital, but I think a large portion of that comes from the warmth that you get from the filter. There's pros and cons to both, as I say, and this is not exactly a portable thing, but it does sound lovely. And in the hands of a musician like Paul, it sounded fantastic. And that was just him playing on the keyboard and twiddling the knobs on the front panel, just hitting record. That's all he did. No sequencing, nothing else. The other one I wanted to play you, which some of you will have heard if you've gone to my website, is a demo of this thing. Now, I'll admit I cheated here. I did what's called multi-tracking. So this only plays one note at a time. The tune you're about to hear has about 10 parts going in places. So this is basically, I hook the MIDI up to it, record the sound, mute the track, and then to the next one, record the sound, and so on. So I did that 10 times. Most of you know the song. Apart from the drums, everything's done on this. So there's a nice mix of analog and digital sounds. You say, I love analog oscillators, but you can't do some of these things with analog oscillators. You don't get any points for guessing what the tune is. In all the bands I've ever played in, there's a reason I don't sing. I can't sing for toffee. So the other thing I thought I would show you is give you a quick overview of some of these things. I'm going to turn this down. I'm hoping that's down. So here we have, this is a little synthesizer. This is one I called Zyra. All my products are named after arcade games from the 80s, because it seemed like a good way. So you've got Gorf, you've got Tron, That was Juju, there was Zyra, and there was a Gauntlet, and there was a Defender, and all the rest of the games, 10 best. So yeah. Yeah, see, people remembering the games. Juju and Zyra was a cheat because they were actually pinball machines. Because I wanted something that was 4 characters long to appear on the display. So. And there was no more arcade games left. So this is quite a simple synthesizer. This is in structure a monowave in a box, in a little pocket-sized box. You've got 2 digital oscillators. You've got 1 sub oscillator. You've got 2 on the monowave. You've got a 24 dB low-pass filter, so it's a similar sort of filter to this in the monowave. You've got 2 envelope generators. Again, we've got the same here. You've got an LFO, and you've got the ability to route the velocity, so how hard you hit the note to some parameters. Typically it's used to route to the VCA, so when you press a note quick it gets louder. In this one you can route it to the waveform, so you can have it change waveform as you play in the same notes. There is another demo I could play where it uses it to fantastic effect, but I don't want to just keep playing any demo tunes. So this box, this is the thing that got me back into synthesizers. This is the Gorf, this is a little sequencer, and as I say, it lets you play 1 note at a time. I'll stop button down. It lets you play 1 note at a time, and you can change the notes that you play. So when I press this note, there you go. So I can change the pitch of the note. Not going to sound very musical. I can turn notes on or off, so I can turn that one on. I can turn that one off. I did tell you I wasn't a musician tonight. So you can do that. You can load 2 patterns together, and it will play one and then play the next one. So that's 2 separate patterns. There's a good chance this is going to be. There goes another pattern, and that's a good chance there's one full of junk. Hey, it wouldn't be Blue Peter without it, would it? So, oops, that's the wrong one. That's what that does. Let's put something in that's got some sound in it, shall we? Instead of some weird bleepy noises. There we go. So I'll demonstrate some of the features. You might have to listen to this rather boring sequence for a bit. So let's start with the oscillators. Oop, come on. There we go. So here I've got 1 oscillator playing. It's playing a sawtooth waveform. If I go and open the filter up, you can hear it's quite a rich waveform. And I can have a sine wave, quite a smooth, clean one. I think next one's a square wave. Some organy ones, some digital ones, there's some sort of vocalish ones in there. There's all sorts of things in there. It's quite a vocally one. So there's lots of different waveforms in there you can have on each oscillator. So then I can bring in the second oscillator, and this is where you get a lot more warmth to the sound. So on this one, getting a bit loud now. I've got 2 oscillators, one tuned an octave below the other. I can put them on the same pitch, oops, there, and I can just detune a little bit. It gives it a bit of warmth and sort of shimmery depth to the sound. Or I can take it down an octave again. Then we move on to the filter. Remember from the other diagram. So here I've got the cut-off set right open, so I'm letting through all the harmonics. I can bring it down. I can bring it down. So remember that's still 2 sawtooths that are quite bright, but I've just killed off most of the harmonics. What I can do is use one of the envelopes to sweep that filter. So you get quite a bright percussive attack, and then it decays to something a bit more soft. One of the other things you can do with filters is, have any of you played with filters before in the past? A few people. So you can, the way the filter works, you can turn up what's called the resonance or the Q factor. It's a damping factor on the filter at the point which it cuts off. It's effectively like adding feedback. So if I turn it on again, I can increase that Q factor, and it takes some of the bottom end out and you get the peakiness of the curve. If you go too far, you get the full feedback, which is a sine wave. Then we've got the envelopes, so you can hear it sweeping up. If I turn the decay off, just a simple basic, almost nothing to it, just bring in a little bit of the, you can hear it fade in and fade out. Quite good for brass sounds. Got an LFO, which I can route to various things like the pitch of the oscillator. This is going to sound weird. There you go. And I can change the rate at which it does that wonderful noise. It's a bit of a severe example, but you can use it to get, if I go back to something vaguely normal, and put just a little bit on it, it just gives it a bit of movement in the sound. And you can also do all sorts of other funny things. So this one I'm using the velocity, so how hard the sequencer is hitting the key on the keyboard to change the waveform number. So it's quite a flexible thing, and again, I always keep knocking analog oscillators. They're great, but you can't do that with analog oscillators. If you do it a lot in a sequence, you can get quite a sort of a rich harmonic sequence going that can almost just have a single note pressed. And by changing the waveforms, you can create a sort of rhythm and sort of liveliness to the sequence just by pressing the same note 8 times.
So what's the bill price for that box?
This one?
Yeah.
What's the bill price, or what's the price to sell it for?
What do you sell it for? I'm not trying to find out how much you
So, I was selling these for £250. It doesn't cost me that much to make. I'm not making the same mistake as I made with the mono end.
So if you put some kind of like MIDI key router in front of it and bought 8 of them, then you could have a polyphonic one.
Yep. I've got a stash of these back at the office and I'm tempted to do that.
Is there such a thing? Does it exist?
There are things out there that will do that. But I keep thinking I should make one, and then
I was just thinking it'd be a nice thing to build, wouldn't it?
Yeah, but the problem then is I've actually got a day job now. I kind of need to build this next product. Once this is out the door, then I can have some things to play with. But yeah, that's the little synthesizer. I'm a huge fan of the 80s. Most of my teenage years were in the 80s, so I spent a lot of time there, and I loved a lot of the music. Now, quite a few of you remember bands like Depeche Mode and Human League and all that sort of thing. And one of the things they were best known for was a drum machine called the Lindrum, which was about that wide, about that deep, about that tall, cost about £4,000 in about 82, and played drum samples from EPOL. So I wanted to build one of those, but I didn't want to pay £4,000, so they'd go for silly money on eBay now. So I built this thing, and this basically plays back waveforms from some classic drum machines. One of them's the Lindrum. There's also an Oberheim DMX and a Simmons SDS5 in there. So I've got a nice bit of 80s feel going on. And you can play, there's a bass drum, snare, cowbell, hand claps, toms, that's a tambourine, yep, a hi-hat, and a crash cymbal. Now, what's special about these sounds is Roger Lynn's actually a very clever bloke. Back in the 80s, EPROMs were mind-numbingly expensive. You know, so he came up with a clever way. 8-bit samples sounded terrible. So he came up with a clever way. He used logarithmic DACs for his. So effectively, he gets a sort of 13, 14 bits of resolution out of an 8-bit EPROM. So it gave his sounds a real punch and a real edge. me being a glutton for punishment, wanted to replicate that. So in this one I've got the contents of the original EEPROM, and I have a little conversion, takes it out, converts it to ULAW into 14 bits and pushes it out of the DAC. So it's another reason for doing it in assembly language. And I cheated, I used a lookup table for doing the conversion. That's why it's a big chip. So it means I can play multiple parts. I start off with something quite simple. Yeah. Oh, if I put the hand claps on, everybody loves hand claps.
So are you playing the MIDI sequence into the drum machine?
Yep, so again, this is much like the sequencer before, but this is playing drum parts.
Yeah.
This is playing different hands on a drummer. You can play 8 parts at the same time on here, whereas this plays 1 note at a time, but you can change the note. This plays 8 things, but you can't change the note whilst it's playing. You can change which ones are on or off. So that's generating that. The advantage of doing this with digital is I can change the pitch. Really low. Like your hand claps. Which you can't do again with analog stuff. And again, I like the sound of things like TR-808. I think it's a beautiful sounding machine. But it's quite big and it's quite chunky. And again, I think it's a bit limited in what it can do. And that's through no fault of Roland's design. That was what was needed at the time, and it sounds great. But I think there is a healthy balance to be had between digital and analog. And I think people obsess about analog a bit too much. But what else is there? There's this thing called the monowave, which I think is on. Yeah, I can see flashy lights. Now, this sounds quite different to the others. It is a lot bigger, a lot richer sounding machine. Is that the out? I wish I'd have labelled those sockets more clearly. Oops. Let's turn the volume down. Yay, no sound. So let's come around the front and see what we've got. So the thing to remember about this is these are all connected. I'll tell you why we haven't got sound. So you have to plug the MIDI in, it works, doesn't it? There you go. So there's nothing between this knob and the circuit it's controlling. There is literally a piece of wire. There's no digital processing, there's no sampling, there's no DACs, there's no ADCs. So when I turn that, it's actually changing the voltage on the circuits itself. Same with the filter resonance. And it's quite a different sounding beast. But again, you've got the... If I turn off the source layers. So you can have the digital sounds if you want. Sounds quite analog. And again, I think a large portion of it is down to the filter. I don't know anyone when they played this that's thought it was digital oscillators until they suddenly discovered there's 256 waveforms instead of the normal 3. Then there's lots of pros and cons. I teamed up with a guy called Axel Hartman. Anyone ever heard of him? No, he created a synthesizer called the Hartman Neuron. Big synthesizer. I can't remember how many thousands of pounds it was at the time. And he was looking for a follow-up product. So he and I worked on a thing called Tempest, which was a 4 oscillator per voice, big synth, lots of envelopes, lots of filters, and lots of modulation and stuff. And this was the prototype voice card that we used. There was going to be LEDs on that. Now, one of the problems we faced was the cost. So, if you want 8 voices, you've got to have 8 of those in there. To get this made in this country would cost £500 per voice. Right? get them made in China, $116. So about £80 at the time. Okay, I know it's cheap labour and so on, but when you're looking at developing a new product, you can't ignore the economies of scale when you go to somewhere like China. We worked on the product. We had a nice front panel, a nice case, and I think anyone who's been to my website or my Facebook page will see the picture there of the synthesizer we were going to make. And basically, it would have cost us about £4,000 to sell. And at the time, this was 2004, nobody was willing to pay that because everyone was swapping to software synthesizers. So we canned the project, and about 2 months later, we went bankrupt. Axel Hartman's a really nice guy. He does a lot of design for companies like Waldorf. Anyone played with or seen the new Moog Slim Fatty and Fatty 37 or whatever it's called? He's done all the design for that. He does the ones for Virus, he does the ones for some of the Novation stuff. He does pretty much all of the synthesizer design for us. Now, we contacted him and said, would you have a hand in our design? And he said yes, and we did a little bit of work with him, but in the end we decided not to go with him because we thought we had a good design. So one of the things that I'm enjoying doing this now full time, which I've been doing since February, is when you're doing this on your own in your hobby as a spare time, you have to do everything. You have to do the case, the software, the hardware, programming, design it, market it, get the web page updated, do the end demos and all the rest of it. It's a lot of work. Now I'm doing this full time. We have, on this project, 8 people working on the project and various bits and pieces. Some doing stuff I can't talk about, some doing stuff I can't talk about, and some doing stuff I can talk about. So we've got a couple of software programmers. We've got a guy doing the graphics. He's helped all the graphic design and the user interface design and bits and pieces. And the case and everything, and it looks stunning. I have to say, it is, if I was to have tried to build this on my own, A, it would have taken me about 5 years to get to where I am now. B, it would not look anywhere near as nice as it does, and C, it just wouldn't have sounded the same. It is a world apart from doing the DIY stuff. I still enjoy mucking around with the DIY stuff, but I love doing what I'm doing with this proper product, a full-on product that's got a proper team behind it and a whole infrastructure. It is a whole new league. And it is, these are great products and I love them, but this is several steps up in terms of quality, in terms of sound, the look, the feel. And I go back to the guitar analogy. This is a PRS for a keyboard player. This is going to be a really beautiful instrument. Not just a keyboard, not just a synthesizer, it's going to be an instrument. So I'm about out of things to talk about, I think. Has anyone got any questions? Hey! I've either bored you to sleep.
Who are you going to market your new synthesizer to? Musicians? Studios?
Yes. Yes.
Okay.
Yeah. So it's not going to be a cheap synthesizer, to be honest with you. It can't be because it's an analog digital hybrid, so it's big. It's costing us, I can't tell you how much the bill of materials is, but it's a lot more than I would have expected. But everything is top quality. The market we're aiming for is the people who make money from music. So I was explaining to somebody, I think it was yourself, about the demographic. There are 85% of the people out there who own synthesizers who want to make money from it and who love playing with them, which is great. There are 14% who make a portion of their income from music. My friend Paul Nagel's one of them. He writes library music and stuff. There is 1% that is the professional music. These are the Hans Zimmers of the world. The Jean-Michel Jarre's, you know, the people from some of the big pop bands. We're aiming for that top 15%. Well, I'm not going to stop anyone buying one of my synthesizers if they want. Yeah, great, give me your money, you can have one. But it's going to be a considered purchase. We want people to feel wanted and part of something. back in the 80s, there was a shop in London called Psychosystems. And everybody aspired to go into this shop. And there was 3 levels. Anyone